Geometry, Chapter 10, Lesson 1, and we're going to begin a section of material where we look at areas of different polygons. We're going to begin with areas of parallelograms and areas of triangles. We've talked about this in class a little bit already, that any side of a figure can be a base. It doesn't have to be the one that's always on the bottom. So any side can be a base, and the altitude is anything that's perpendicular to that base, and then that altitude, or the length of that altitude, is the height of the figure. So as you look in these diagrams here, you can see a dotted line or dashed line drawn perpendicular to this bottom piece. So this side that's in pink is a base, this dashed line is the altitude, or would be the height. If I choose to make this left side as my base, I need to draw a line perpendicular to that from the other side in order to determine the altitude or create a height. And to do that, we draw it on the outside. Now this is not adding anything to the parallelogram, it's simply extending these lines out so that we can draw an altitude or a height of the figure. And I'll talk a little bit more about that more in just a moment. The key thing that we talked about in class, remember, is that the height has to be perpendicular to the base that you choose. So you can choose any side to be your base, but the altitude or the height must be perpendicular to the side that you've chosen to be your base, and that's going to be important when we look at the formulas for calculating the area of these different figures. In the first formula that you'll need to know is that the area of a rectangle is the base times the height. Now rectangles are kind of nice because it doesn't matter what side you choose to be your base, the other side that's connected to it is perpendicular, so you already have a height and a base depending upon what you've chosen. The nice thing about formulas, remember, is that any variable in the formula can be determined as long as you know all of the other ones. In other words, in this formula we have an A, we have a B, and we have an H. And the beginning lessons, or the beginning part of the lesson, you're going to be given B and H most of the time, and so you calculate A. But that's not the only way that the formula could be used. If we give you the A and the B, then you could figure out the H that goes with that B. Or if we give you the value of A and H, you can figure out the B that goes with the H. The formula can be used in multiple ways, not just for substituting in a B and an H, a base and a height, and determining area. It's much more valuable than that if we remember our algebraic properties. The key is being able to know, or the key is knowing what those variables represent, and then it's simply a matter of algebraically substituting in and solving for the one that you don't know. Multiple calculations may be needed to determine the answer to a question. In other words, you may have to use the formula twice in the problem to get to the answer that you are asked to determine. The area of a parallelogram, you'll notice that this is exactly the same formula as the area of a rectangle. And again, the important thing here is to notice that if you take your parallelogram, the sides of the parallelogram are not perpendicular to each other. So while this may be your base, this side is not the height because this side is not perpendicular. So it's important to remember what we talked about, that the base that you're going to put in here and the height number that you're going to put in here must be values that are perpendicular to each other in the diagram. Any side that you want could be the base, as long as the height that you use with that is perpendicular to that. The key is that the height and the base that you use must be perpendicular to each other. So a couple of quick notes about how diagrams are drawn. Dotted lines or dashed lines are not part of the figure. They are simply extensions of a side or an altitude that's been drawn in for reference. In other words, if you're asked to determine the area of this parallelogram, you'll notice that the shaded area in orangish color, that's the area. You'll notice that on the outside we have these dashed lines that if you take the two dashed lines together and you look out here, many students want to look at this triangle as part of what they're trying to figure out. This triangle that's created is simply created because I'm extending the side of the parallelogram so that I can draw a height that's referenced as perpendicular to this base. So dashed lines are not part of what you're trying to figure out. If you're asked for the area, what's enclosed by these dotted lines, if it's not shaded, is not part of the figure that you're trying to calculate. These are only for reference. These are only give us, what they're giving us is the information that we need, that this dashed line segment here is perpendicular to this, so if I wanted to use this value in my formula, I could. So don't be confused by these dashed, I guess that would be dotted and dashed together, dashed lines. I think I just created a new word. So these dashed lines are simply reference lines and are not necessarily part of what we're trying to use or part of the area that we're trying to calculate. Very quickly then, if we wanted to find the area of this parallelogram, I have this altitude of 4. This is the only one that's given to me that's perpendicular, so while 4.5 could be a base, I can't use it because I don't know any sides is perpendicular to it. So if I'm going to use the 4 as my height, I must use 5 as my base, so substituting those values in, I would get an area of 20 inches squared. In this parallelogram, again, we can't really draw an altitude inside because of the thinness of the figure, so we extend the base here and we draw this line down. So these dashed lines out here are simply reference lines showing me that this 3.5 is perpendicular to this 2, so I can use those two values in my formula as I want to calculate the area. Now very quickly I want to talk about some things that I'm going to require you to do in order to create full credit or get full credit. And the reasons behind it are many. One is it's a way to help you memorize the formula. Secondly, if you get an incorrect answer, it allows me to see why you got it incorrect, and then I can help you correct your mistakes. It also helps you see where the units come from and why the units are squared rather than not squared. It will also help you in the future when we do volume in seeing why the units for volume are cubed and not squared. And it really eliminates the need to try to memorize, okay, when I'm doing this, I use square units. When I'm doing this, I use cube units. When I'm doing this, perimeter, I don't use anything squared or cubed, because I want to show you how the units, when you use the arithmetic with the words, creates or shows you what those units of your final answer should be. So the first thing you have to do is you must write the formula that you're going to use. Okay, I don't want just numbers on your page. I want to know what the formula is that you're using. It's a way for you to memorize the formula. It's a way for me to tell if you've chosen the correct formula to use, and it also tells me if the formula is written wrong, that you haven't memorized it yet, and that's going to be something that you're going to need to work on. The second thing after you've written the formula is to then substitute the values into the formula in the appropriate place. Again, this shows me that you understand what the letters represent, and then from the figure where those values go in the formula. I want you to include the units in this step because I want you to start practicing using the multiplication of units and the division of units to see how those work. This will help you when you do your chemistry and your physics later on, as many of the units that you use in those courses require you to work with words and apply multiplication and division to words so that you can see where the units come from. And then your final answer must have the correct units. And if you do the work here, substituting in with the units and then mathematically creating the units, you'll always have the correct ones. You won't ever have to guess whether you're using the correct units or not.